Hello everybody, myself Jyoti and this is fifth lecture on vector atom model, and today we are going to discuss about multiplicity and term symbols, and this topic is very important from the competitive examination point of view as well. So we are going to solve certain numericals or certain problems related to multiplicity and term symbols, but before that I want you to understand a little bit of theory behind multiplicity and term symbols. So, orbital state of an electron and an atom. So, when I say that, when I want to describe the orbital state of an electron, I use small letters S, P, D, F, and so on. What is S state represent? Small s state. It represents that the L is equals to 0. Orbital angular momentum is 0 for that electron. L is 0. When it is in P state, that means L is 1. When it is in D state, that means L is equals to 2. When it is in F state, that means L is equals to 3, and so on. As we are describing the state of electron in a similar fashion, we can describe the orbital state of atom, and for that we use capital letters: capital S, capital P, capital D, and capital F. And total orbital angular momentum of the atom, it is L is equals to, capital L is equals to 0 for capital S state, capital L is equals to 1 for P state. So suppose I have an atom for which L is equals to 2, total angular momentum for that atom is 2. That means that atom, it is in D state, that way. Now, what is multiplicity? Due to spin-orbit interaction, each orbital state shows a fine structure, and it splits up into number of substates. So L equals to 0 state, it can split into substate. L is equals to 1 state, it can split into substates. L is equals to 2 level, it can split into substates. So the number of substates in which a corresponding orbital state splits up, that is called as multiplicity of that orbital state. So when S is equals to 0, each L level, it remains singlet, and capital J, total angular momentum, it will be only because of the orbital angular momentum, because for that case S is equals to 0. S is equals to 0 here, so total angular momentum of the atom, it will be only orbital angular momentum. When S is equals to half, each L level splits into doublet corresponding to J equals to L plus half and J equals to L minus half. When S is equals to 1, each level splits up into triplet. So we will have L plus 1, L minus 1, that way. Now what do we observe here? We observe that in each state, the multiplicity of an orbital state, it is given by the formula 2s plus 1. So when S is equals to 0, I will get 1 state, singlet state. When S is equals to half, I will get half into 2, that is 1, 1 plus 1, 2. So I will get doublet state. When S is equals to 1, 2 into 1, 2 plus 1, 3. So it is a triplet state, that way. So multiplicity of a state gives the number of different possible orientations of vector L and vector S, and hence the number of different possible values of vector J for that state. Now, term symbol. It is very important to understand term symbol. So term symbol may we represent a state of an atom using a letter. So suppose it is given that L is equals to 1. That means my atom, it is in P state. If it is given L is equals to 0, that means my atom, it is in S state. So first thing is writing letter. So capital S or P or D, depending upon total orbital angular momentum for that particular atom, you will write a letter. So suppose my atom, it is in is having L is equals to 1, so it is in P state. So I will write down capital P. Now to this capital P, I will write down a superscript. What is superscript? Superscript will be nothing but the value of multiplicity, and multiplicity is given by the formula 2s plus 1. So superscript, that is multiplicity, then the state in which an atom it is, like S state or P state or D state, that is written in terms of a letter, and then subscript, it represents the J. So that is how the term symbol is written, and this representation of the state, it is called term symbol. So this is about the term symbol. Now what we will do, we will solve certain problems related to term symbols, and then everything, what is multiplicity, what is J, how we are writing exactly the terms, all that will become very much clear to you. So let's solve. Hello, so now let us start solving the problems related to term symbols, multiplicity and J values so that you will understand the whole concept. Now what is meant by 2p state? What terms does it include? So 2p means जो superscript होता है that always tells about the multiplicity. Superscript जो है that gives you multiplicity. Now multiplicity is 2. Multiplicity क्या होता है? Multiplicity means that the given orbital state it splits up into substates. So that is nothing but the value of multiplicity. यहाँ पे कितने substates है? We have 2 substates. So that is called as a doublet state. 2p means doublet state. And which letter we have used over here? P. So if the letter is S, L is equals to 0. If letter is P, L is equals to 1. If letter is D, that means L is equals to 2. That way. So here as we are having P state, that means orbital angular momentum L value, it is 1. So 2p में 2 represents how many substates are there. P represents the state of the atom, so which gives L is equals to 1. Now we know that multiplicity formula is 2s plus 1. So 2s plus 1 is equals to 2. So 2s is equals to, I will shift this 1 to this side, so I will get 2 minus 1. 2s is equals to 2 minus 1, that is 1. So s is equals to, I will divide both sides by 2, so I will get s is equals to half. So I'm getting this. So what I have L is equals to 1 and s is equals to half. So we know that J values are given by L plus S and L minus S. अब मैं L plus S करूंगी, so L is 1, S is half, so 1 plus half is 3 by 2. And when I will do L minus S, L is 1, S is half, so L minus S, that 1 minus 1 by 2, that is 1 by 2. So I'm getting J values as 3 by 2, 1 by 2. So the terms, how I will write down the terms. So when I told you about term symbol, I told you that we write a state, यहाँ पे P state है, and then we write down multiplicity as a superscript and J value as the subscript. Multiplicity, we already know that it is a doublet state. So 2p, and we have 2 values of J. So 2p 3 by 2 and 2p half. These are the term symbols. Or we can combine these 2 values of J and we can also write it as 2p 3 by 2 comma 1 by 2. Okay, let us take, so how do we read 2p 3 by 2? So 2p 3 by 2 is read as doublet p 3 whole state, and 2p half is read as doublet p 1 half state. That is how you read this term symbol. Let us take one more problem. Write the J values for 3p state and 1p state. Now 3p, 3 represents the number of substates, or it represents the multiplicity. So 3p means it is triplet state. And again we have p, that means L is equals to 1. So 3. So 3, it is nothing but multiplicity. Multiplicity formula is 2s plus 1. So I have 2s plus 1 is equals to 3. So 2s is equals to, I will shift this 1 over here. So I'll get 3 minus 1. So 2s is equals to 2. Imply s is equals to 1. And p represents L is equals to 1. So what I have, L is equals to 1, s is equals to 1. So when L is equals to 1 and s is equals to 1, J can take values from L plus S to L minus S. L is 1, S is 1, 1 plus 1, 2. L is 1, S is 1, 1 minus 1 is 0. So J will take values as 2, 1, 0. So here I can write the term symbols 3p2, 3p1, 3p0. This 3 represents multiplicity, p represents L is equals to 1, and 2, 1 and 0. These are the J values. Or alternatively, I can write this as 3p and I can write these J values together like 2, 1, 0. So either you can write like this or like this. Now second is, we have to find out for this also J value for 1p state. 1p. So 1 represents multiplicity. So 2s plus 1 is equals to 1. 2s is equals to 1 minus 1. 2s is equals to 0. Imply s is equals to 0. And p represents L is equals to 1. So J Here I will have J equals to L is equals to 1 because S is 0. So total angular momentum it will be only because of the orbital angular momentum. So total angular momentum it is equals to L. L is 1. So J is also 1. So here the term symbol will be 1, P and J value. J value is 1. So 1, P1. And it will be read as singlet P1 state. Let us take one more example. Find the terms arising out of sp electron configuration using JJ coupling. Now sp configuration, what does it mean? It means that I have two electrons. One electron it is in S state and another electron it is in P state. S state, we know that if S state is there, L is equals to 0. For P state, L is equals to 1, D state L is equals to 2 and so on. So as this electron it is in, now we are not talking about atom, we are talking about electron. That is how I have used small l and not capital L. So one electron is in S state, so L1 is equals to 0. Second electron is in P state, so L2 is equals to 1. L1 equals to 0 and I have S1 is equals to half because spin is half for the electron. So when I will combine, I'll get J1 is equals to half. When L1 is 0, remember this is very important. When L1 is 0, J value it is given by L plus S. एक ही formula. There is no other formula. So L1 minus S1 will not be the formula. When L1 equals to 0, the formula for J1 is only L1 plus S1 and not L1 minus S1. When L2 is equals to 1, S2 is equals to half. So J2 will have two values, L1 plus S1 and L1 minus S1 because L2 is 1. So except for L equals to 0 state, except for S state, for all other states, J takes two values, L1 plus S1 and L1 minus S1. This is very important while solving numericals. You will have to remember this. So J2 is equals to L1 plus S1, 1 plus half, that is 3 by 2. J2 is equals to L1 minus S1, that is 1 minus half, so it is half. So I'm getting two values of J2, 3 by 2, 1 by 2. Now I got J1 as half and J2 as two values, 3 by 2, 1 by 2. So I'll take the first case, J1 is equals to half and J2 equals to half. And I know that J is given as J1 plus J2. So I will get half plus half, that is 1. And when J is equal, and J1 minus J2, half minus half, it will be 0. So I'm getting these two values, J equals to 1, 0. And second case is when J1 equals to half and J2 equals to 3 by 2. So for that also I will calculate. So when J1 is equals to half and J2 equals to 3 by 2, I'll get J equals to J1 plus J2. J1 plus J2, it will be 1 by 2 plus 3 by 2, that is 4 by 2, which is equals to 2. And J1 minus J2. J1 minus J2 will be 1. So whenever we take J1 minus J2, we take magnitude, modulus of J1 minus J2. That is how here we will not get minus 1, we will get only plus 1. So this also you have to remember that J takes values from J1 plus J2 and J1 minus J2 modulus. And that is how, even if I am subtracting J1 minus J2, half minus 3 by 2, it will be minus 1. But I am taking modulus of that, so it will be 1. So J equals to 2, 1. So I can write the terms are as half, half. So J1, J2, half, half. J1, J2, half, half. I am getting J value as 1 and 0. So J1, J2, half, half, 1, half, half, 0. And when I'm combining J1, J2, half and 3 by 2, I'm getting half 3 by 2. I'm getting two values, 2 and 1. So half 3 by 2, 2, half 3 by 2, 1. Okay, or I can combine these two terms and I can write this together as half, half, 1 and 0. That means when J1 and J2 is half, half, I am getting total angular momentum J as 1 and 0 and half 3 by 2. When I combine this, I am getting J value as 2 and 1 that way. So this is how you speak about term symbols, you calculate J values, you calculate multiplicity, and this topic is very important. So all of you have to do it properly. Thank you so much.